Okay, for people joining this live stream, this is a design meeting about Wolfram language, and it's actually a double header meeting. We will be talking about tools for analyzing code, and then at the top of the hour, we will switch to talking about code robustification and error handling. So we are watching Brenton's screen here, and we're about to start hearing about the first item here, profiling Wolfram language code. So I don't know quite what this is about, so let's take a look.
Yeah, a lot of this is going to be showing, simply showing this functionality. So it is possible to instrument Wolfram language code, and I thought that the first two really good examples of doing that would be profiling code that you run and getting coverage reporting of code that you run.
Okay, terrific. Let's see the examples.
And we have, plenty of other options, but I think these are the main two.
Yes, let's see.
So I have reports, but I can show you what the transcript kind of looks like with.
No, I want to see the whole process. I mean, I want to see how do you do the instrumentation? What do you actually do?
Yeah. So, there's a packlet that you load, and you so the first thing to be aware of that I would like to change in the future is that this operates directly on source code itself, and it's not, it's not in down values or anything like that. And so, maybe that's a limitation right off from the start.
Hold on. We got a raw source file.
Yeah.
And what we're going to get is we're going to run that source file, and then we're going to get profiling information. Is that correct?
You will after you've instrumented the code.
Yeah. No. I'm trying to understand the workflow.
Stephen, the source file gets rewritten, and it's files. It's all of the Wolfram language code in a folder. It's rewritten to add instrumenting data, and then it gets executed and instrumentation.
Okay, so this is a very heavyweight thing. This is not something where you just go into your notebook and you annotate something in the notebook and you do something. This is something where, so
by the way, though, I mean, does it kind of like, I don't know how to put it, like textually instrument it, or does it use like inactivated and stuff like that? Like, does it go in the text?
I think is what you mean. Yeah. So you can see, so for example, this is the original source of like a package. And this would be the instrumented source of the package. And the only difference, this is all full form, but the difference is that there are wrappers that are now inserted around the code that insert the file name and line and, and function name information for all of the functions that you're running, so that you can keep track of that information. So it's the same file. It just has wrappers, around all of the right-hand sides of all of these function bodies, because even though line 12 and line 15 have the same function name, you want to mark them up differently. And so, these have different wrappers, line 29 similarly.
Okay, I get it. So the point is that this is going to, all right. Okay, I get this. Okay, so can you go back? Okay, so the concept of the workflow here is you've got a bunch of source files. You're going to rewrite the source files, and you're going to run the source files and generate some kind of report from them. Is that the idea?
Yeah. Yep.
Okay, and right now, none of this is doable at the level of granular notebook type stuff. It's all just heavyweight, source file profiling. But let's see what it generates, okay?
Yeah, so, and you load and you make sure it's the right thing.
I understand. So
so here,
Well, I mean, we have no idea how you load, because presumably it has a differently named file, which is the profile rewritten version of that file, right? It started off as a .wl file, and then there is a .wlp file or something that is the profile version of that file.
They're in different directories, yeah.
Oh, well, wait a minute. Why?
Well, because you need to manage. So, if we look at the.
Oh, yeah, I saw what you did. Go back to that file.
You need to be able to coverage all,
I get it. Okay. Can you go back to the previous file, the notebook? Okay. Go back to your notebook. Okay. So what you did there was you said there was a source and a destination for the profile instrument thing.
Yeah.
There, right. Okay.
And these are directories.
I know that. Okay, so now profile evaluate down there runs the thing in the profile system. Okay, now how do you get out? I see. So that is the analog of timing or something.
Yeah.
Gets out the profile data. Okay.
And it's heavyweight still enough that there is post-processing that's needed. So you do that with the data, and then you can get the report, that comes out. So.
Okay. So hold on.
Okay.
Okay. Can you run all this, please? Just run this file.
Start
at the beginning. I want to see how long it takes.
Yeah. So that's instructive. And this really is starting from scratch. Well, yeah.
Okay.
So yeah, this is
how big is the file? How big are these files?
Well, this is the entire compile repo. So there are hundreds, maybe even thousands of .m files here.
Okay. You're not using the standardized progress monitoring system.
Correct. Correct.
Why not?
I haven't revisited this. All of instrumentation is due for kind of a
okay, so you wrote this a while ago.
Yeah.
Okay. All right. Fine. Okay.
So it takes about this long. Yeah.
Okay. Fine. So it's the big set of directories, and it takes a while to do it. Okay.
Still, though, if you're talking hundreds of files, that's not bad.
It's not terrible. Yeah.
Yeah. And I've actually profiled itself, to find the bottlenecks and everything. So.
Okay.
You can ignore that message for the moment because.
Okay. No,
but,
just sufficient to just tell us to ignore the message.
Yeah. So function compile of just that. So now you have some profile data. And then you get a report back about how long everything took. And so the top one's kind of a long directory name there, but so what you can see,
is
the
this
number
a data
one
set?
thing you probably care about
is this a data set?
Chris Carlson has made this into a data set, but I have not brought those changes into.
Okay, so fine.
Yet,
So,
but there is something floating around. Yeah.
Okay, so it should be a data set.
Yeah.
Okay.
And so so you can see, create instruction visitor.
I get it. I can see what it's saying. Okay, so wait a second. So then it's sorted like that. Okay. All right.
Yeah. So.
Okay.
Does dataset have a sorting interface in its typesetting? I don't remember.
Yes.
Yeah, because sorting, interactive important. Sorting for a report like this will be really critical, I think.
Yes.
Wait,
yes,
does it? I thought that dataset, I thought it just has minimization things, unless this is brand new.
It's new.
Okay.
Does
it sort in the original data or just in the, like if I have a variable and I sort it in the interactive interface, does it sort the symbol?
No.
Okay.
It's just purely visual. I'd really like to see the dataset version of this, but
sure.
This looks highly useful. Okay. All right.
One thing, I'll show the pie chart in a second, but everyone take note. So, you have anonymous functions here, here and here and here and further down. So just remember that. Everything is computable. You can get a bunch of data out and do whatever you want with it. And so I just made a pie chart of, the self-time percentages. And you see the second one is actually function, but we're talking about different functions all being added up here. So, that's kind of, all of those should be counted differently. So naively, you're going to, they all have the same name, so they're all counted together, but you don't actually want that with anonymous functions. So obviously, so, just that kind of thing to be aware of. And I cut off at the 10. Yeah. So
the function is just a special exception that functions get counted by their contents as opposed to by just function.
Yeah, it would just be their line number. But I guess even that's not sufficient, line number and column. But and there might be other other function-like things that would have the same name that you want to count.
Well, any curried function is going to have this problem, right? Because its head is not what you think it is.
Yeah.
Sure.
So it's just stuff to be aware of. Yeah.
I mean, function,
Okay.
it's more extreme though, because if you use like select or something, it's, you know, it's reasonable to say, oh yes, select is spending this time. Right. It's just function, because function is just means nothing, right? If you tell it, oh, it spent all of its time in function, it tells you nothing.
Right.
Right. That's why you have to break them up. Yeah.
But these are all different instances of functions. They all occur in different locations, so they could be separated by their instances.
Right, exactly. I think that's what we saw in the last report, is that they were separated. It's just in the pie chart that they're combined.
Yeah. I mean, I don't know what data we're being given to separate them. I mean, it seems like, you know, I don't know, it might be interesting to assign some sort of IDs to them or have some other provenance information that can be tracked in some way. Maybe there is, and maybe it's just wasn't simple to put it in the pie chart. I don't know.
Well,
Okay,
so
so
maybe you could
show
just
the naivety. Line number and column would be enough to, you know, separate them all.
Okay.
Yeah, I mean, arguably you want to just have the whole function body, but you know, you wouldn't want to display it.
Yeah, well, why not? I mean, just iconize it in the data set.
Yeah.
I mean, you could just literally iconize the function body. You could say function
or
and
short,
then iconize.
or short. Iconize seems a little strange, but
well, the point about iconize is, well, it depends on how you're doing it.
Yeah. This is a detail, though.
Okay, let's zoom out for a minute. Okay, so this is a very heavyweight profiling system, which is, you know, and people want things for much more lightweight purposes.
In addition.
Well, in addition, but maybe it's the same thing. Maybe it can be made to be the same thing. Can you go back, scroll back up to the top?
The thing is, though, is that I think that for a lightweight thing, like look, this is doing it lexically, which maybe has a performance improvement for these big things. But I think for like, if I just have a piece of code and I want to profile it, which you can already do using the like runtime with the debugger and stuff like that in principle.
Which nobody ever does.
I occasionally do, but it is also kind of weird. It has some weird properties. But the point is that I think for that, what you want is you don't want to do anything lexical. You just want to do like inactivate and stuff like that. Inactivate style analysis. That's how you would do it in a more lightweight way, but I'm not sure.
Why not do it lexically? I mean, I don't understand. Why not behind the scenes do it lexically? That is, take the notebook contents and do this. I mean, in other words,
well, but you might want to. The point is for smaller things, right? There are two cases. The case of I have a big project, like the compiler project, and I want to profile it. That's this case. The other case is like I have this one particular line of code, and I want to profile it.
Or I have this small function that's 3 lines long.
Sure. Right. And this is the case that the current debugger profiler is set up for. And in that case, I think it's a little crazy to do, you know, to be like, okay, I've made a new line. You know, I've copied down your line into a new line that has a bunch of weird names in it. And then you're going to run this and it's going to produce a report. I think that seems strange.
But
I mean, it's correct for the big case.
But, yeah, hang on. Can I just say something? So, you know, if we had a mode where we could use Brenton's parser to load, you know, Wolfram language code, then we wouldn't need to do this copy file. It's just purely because the kernel parser is too ossified and inflexible to add this sort of information. And the metering, the workbench profiler is using the debugger metering thing, which has a different philosophy. I think what Brenton's doing is actually better. It's more precise and it's more similar to how other languages work. So I mean, this step of, you know, the profile instrument, I mean, that really could go away. I mean, you could just have.
So what you're saying is,
I mean, certainly for the big case, right? Certainly for the project-wide case, that's for sure. But the question is this also the same architecture you want for a single line?
The debugger, the workbench. The parser has to be in a debug mode in order for the profiling to work. And the same thing could happen here. If it's in, you know, debug mode, it could use Brenton's parser, for example, and add.
Right, but so let's look at how that would actually work. Okay, so you're saying instead of Shift Enter, you would have some different thing. What you would do is you would wait.
Debugging.
I'm sorry.
Menu item debug. There's a menu item in the front end.
I know, but it doesn't. It is not something people find usable.
Sure. Yeah. That's
right. So let's talk about how we make it usable. So one possibility would be that essentially we annotate cells with this cell is being parsed in a way, or has been parsed in a way that has this background information. See what I'm saying? So let's imagine that we had a command option shift return thing that is a special way of evaluating a cell, okay, which would tag that cell as presumably having, I don't know whether it would actually have had stuff rewritten in it, or whether it would simply have a thing that says, I'm supposed to be sent to the Brenton parser rather than the standard kernel parser.
Hang on, this is a bit confused. When you're going from the front end, it's sending more information over in the boxes. The front end does that. Okay. Brenton is loading stuff from package files, so it's nothing to do with shift enter. That's just how the evaluation's getting launched. You see that they're different. Different things.
Which is that Brenton's thing runs on strings as opposed to boxes.
Correct. Correct. Yes. On files. Yes. It's parsing files. Yes. Like the Workbench profiler does. Yes.
Okay. So fine. But so what I'm saying is, what he's doing is he's taking a file, he's rewriting it to put instrumentation in it. Okay. What I'm saying is in the front end, you've got to be able to do the same thing. That is to say, this cell I'm going to set to be one that has instrumentation in it.
Right, so you could do that. That is like having the debug menu item at the cell level.
Yeah. Okay.
No more. But Brenton, can you just bring down click on the evaluation?
Yeah.
So it's like having that setting, debugger, at the cell level.
Well, let me see it. Let me see what happens if I do this.
Well, if you do that, then you have to now go and reevaluate code.
So that's not the right thing. That was a bad UX decision.
Well, no, but it's the same as the cell level. Because the point is, once you're in debugger mode, when you run things, it'll run and it'll say parentheses debug, right? So the point is, you just want to do that at the cell level, and then it's. That's what
I'm suggesting. I'm suggesting that you tag the cell, you convert it just like you can convert to traditional form or something. You convert to a form where.
Right, that's what this does. This just changes it so that the default is, it just changes it so that every time you run a cell, it'll now be in debug mode.
Exactly.
But
you don't have a visual indication that it has been debugged, right?
You do actually. So if you press debugger actually, and then
shall
try
I
running
do this?
something.
Why don't you stop sharing? Anton, why don't you stop sharing?
I mean, another possibility is that we should always send this debug info.
No.
I mean, I have to imagine there's some performance.
Serious performance issue, and it's completely irrelevant to most people.
Well,
hold on.
The performance issue, one of the goals with my new parser is to completely overcome whatever performance issue there would be with providing this information from .wl files. Just better engineering of the parser. I believe that it should always be on. This information should always be on.
I'm sorry, you're completely losing me here. What are you talking about?
So when a package gets loaded in the kernel right now, unless it's in debug mode, there's no information about.
I know there's no instrumentation. I'm well aware of that. So you're suggesting that, hold on. You're suggesting that in the data structure that is kept where? In that the annotation information, the lexical annotation information, be preserved in the kernel. Is that what you're suggesting?
Yeah.
For example, in the down value structure somehow.
Well,
at least
be specific. Be specific. Where does the evaluator? The evaluator is not going to have to dig through lexical annotation information to evaluate something, correct?
No. It'll be something off on the side. No, at runtime, there won't be any performance hit. The performance hit.
How will it be achieved? By hashing or what?
Loading time.
No, but wait a minute. Will it be achieved by hashing or what? How will it know what the corresponding? You could do it with hashing, for example. You could say take this piece of code, maybe you could do it that way. Where do you keep the tag that is the information about what the lexical?
Well, the expr pointer itself could just be is just the tag.
That's how the debug parser, it uses the expert address.
Okay, fine. That's perfectly reasonable.
There are negatives with that, because when you start sharing expers, like symbols are shared or the empty list, then
that's a disaster.
It falls to pieces. Yes. So I think Brenton's method is kind of better.
What is Brenton's method?
Well, he's adding annotations into the code, which can get stripped out.
No. That's not going to work, because then the evaluator has to dig through the annotations. That's not going to work.
Well, hold on. We could have a processing step where, in normal cases, that gets thrown away once, or it gets stored in some.
It seems like a very bad idea. This seems like building a very giant structure for a very special case. Not a good idea. Okay, so let's retrench to try and think about a better idea. Okay, because that's not going to work.
Right. I mean, I think at some level, right, if you care about profiling a whole package, this system is basically correct, right?
Yes.
And just point it at a folder or something like that, have it annotate, whatever. And if you're profiling a single line, then I think an interface that is closer to the debugger one, although probably, I mean, like, look, the question is, why don't you just have a top level function that's called profile or something like that, that basically does this, and it uses it probably doesn't do it lexically, it probably uses inactivate and stuff like that, and it and it will probably have a performance hit, but it doesn't matter because it's just when you're profiling it that it actually
yes, I
makes
agree.
these changes.
Right.
So
I mean, so what we would look at there would be, let me just find a random piece of code here to use this on. Hold on 1 second.
And I mean, it seems like maybe okay, I don't know the details of how the debugger profiler works, but maybe it's doing some magic low level stuff in the evaluator to make it so that it doesn't make a significant performance hit. But it seems like that doesn't. Sorry.
Exactly, it's doing magic low level stuff in the evaluator. I don't like it.
Right.
So.
Okay.
Well, right. So the point is, I think that in modern times, you can just do this. Just use inactivate or something like that, and run the pieces separately, and don't worry about the performance hit. It just doesn't matter that much, I think.
Actually, so
what's that?
Sorry.
I don't understand what you just use inactivate means.
Okay, what it means is you type this. You type profile, and then you say profile evaluate, for example, of Turing machine, whatever it is, causal graph. And then what it presumably does is it takes, what would it actually do? It has to go through and find the definitions that are going to be used here. It would use the same kind of definition finder that we use for cloud deploy and so on. And basically find the definitions, create a shadow version of these definitions that is like Brenton's separate separate directory, create a shadow version in which everything has been inactivated and tagged, and then run it. See what I'm saying? So in other words, it's doing, or it could even do, if it wanted to, it could even do exactly use Brenton's code, and that might be a good idea, where essentially what it's doing is the exact same thing that it would do if I were to say cloud deploy of this thing. It would go down and find the dependency chains, get the code, write the code out somewhere, annotate it with Brenton's stuff, run it, and bring back the profile results. Now, the only difference would be that instead of having explicit line numbers, because it doesn't really have line numbers, it would have to, when it picks up the code, it would somehow have to have cell ID information. Does that make sense to people?
Well, why cell ID? I mean, why is it not just by definition? Like why does it even need to? Okay, in this case, I don't even think it necessarily needs to tell you, where in your notebook it came from. It can just tell you this is the function name. It spent this much time.
I think that's kind of the watershed line here is you're either in a mode where you are trying to track things back to some concrete syntax representation, or you're in a mode where you don't care about concrete syntax at all.
Yeah. Well, fine. But I think profile evaluate, in a first approximation, we could exactly use Brenton's code, basically. We just write this out into a temporary file, run Brenton's code, do the evaluation, bring back his profile report. Just all packaged in a way that's easy for people to use for small granular cases. And
yeah, I mean, the only case,
yeah.
Yeah, I mean, the only minor complaint, this is not a real complaint, is that, this sort of lexical turn it into a string approach, though it's the correct thing for packages, is a bit ugly for small pieces of code because it's just like you don't need it. But
well, I agree, but at least we could get this up and running and see what it feels like.
Yeah.
I mean, right, Brenton, you understood the idea?
Yeah, I mean, if the code's already loaded, it could create confusion in the kernel too. I mean, there are issues, like if there are
okay, so I've got a different idea. Okay,
function.
guys, why not run it in a separate kernel? Why not run profile evaluate in a separate kernel?
Yeah.
We should think about that, Brenton. You can swap down values in and out.
Yeah.
I mean,
no, don't do it that way. I don't think that's a good way to do it. I think that's worse than having something. Probably. I mean,
why?
I'm not sure. I just think it's cleaner to do this, to be a throwaway kernel that does it. But okay, so now if we were doing this, we have various people on our live stream saying that we got one person with 16 years in usage and 7 or 8 years of usage. Nobody has understood the debugger. So possibly Tom and Christopher are the only people on this.
The front-end debugger or the workbench debugger?
Well, I don't know. I think people are referring to the front-end debugger.
Right.
Okay.
I mean, yeah, it sort of works. Sort of.
Okay, look.
That's the thing about the debugger, is that it's like there are various things in it, like even stuff like highlighting a head, the head that produced a message and stuff like that. There are things like that it does that are actually very useful, but it's just that nobody ever does it because it's kind of arcane.
Well, and because of this tagging, this need to do tagging that people find obscure and not easy to understand.
Yeah.
And I mean, I think it would help a lot the best thing would be if it didn't. If it could do the tagging itself automatically and then remove the tag, it could tag. And for example, if you want to run the thing it could tag and indicate in the cell bracket that has done the tagging. If you say, oh, I want to run this as fast as possible, I don't want all that tagging, you just go click it somehow and it detags itself, or it gives you the version that doesn't have tagging.
So why do you what is the advantage to sort of statically tagging? Like, okay, because right, in the Brenton case, right, the case of the big packages, then of course it makes sense because you just want to insert the tags and be able to run it and profile it and change it, etc. But in the case of a single line of code or a few lines of code in a notebook, the thing I don't understand is why you can't just, when you run it, it'll add the annotations, it'll add the tags, it will evaluate it, it'll collect the information from the tags, and then it will produce the results. I don't understand why you need to have tagging as a separate user level step.
Tom?
Because it just won't take a long time.
So I mean, it has to be connected. I mean, rightly or wrongly, the Workbench parser ties the code to lines of source code because you want to see your source for, when you hit a breakpoint, you want to see what code are you actually running, so you could understand it and maybe fix it.
You know what I think we need to do?
Right.
The next segment of this meeting is going to be about the confirm and close mechanism. And maybe what we need to think about there is something in the confirm mechanism that allows you to have a breakpoint.
Breakpoints, or another thing would be like line numbers and stuff. I mean, I think this comes back to what John said earlier, which is basically that there are two cases. There's the case of I'm working on a package, I care about where my errors are occurring, in the plain text of my code and so on, because I have a lot of it. And then there's the case of I'm in a notebook and I have 2 lines of code and I'm trying to profile. I just don't care.
Mm-hmm. To be clear, I wasn't making the distinction between notebooks and text files. I was making the distinction between I have a representation, whether it's in a notebook or a text file, where I want the system to be able
to care about the representation.
To point me to the specific character offset, line number, box, whatever, as opposed to I just don't even, just act like, the code got in there from the ether and just give me a report, based on definitions.
How do I switch off the debugger? Now I'm totally afraid because, what do? I just check that off?
Yeah.
Now nothing bad will happen?
Correct.
I can run the session. I don't have to restart the session.
In fact, all the definitions are already there. You don't have to even rerun anything.
Okay. All right. So look, I think, heading for a profile evaluate that works using this rather hacky mechanism that I suggested that can just directly leverage Brenton's existing code seems like a useful experiment to try. And then with respect to, so Brenton, you can go. Why don't you share again?
Okay. Yep.
Okay. So then what we're looking at here is you're saying you're going to run this. So I don't really understand why. So profile evaluate for you here does not pre-run the profiling. You're doing a separate step that pre-runs the, it will be basically create profile, create profilable version is that first thing there, right? The thing that up at the top is create.
That's what it is. Correct. Yes.
Right. So profile instrument is create a profilable version there.
Yep.
Right. And what similar thing do we have that takes a directory and returns a directory?
Copy directory.
I'm not sure. Are you trying to find analogies with?
Yes, I'm trying to find analogies so we know what to name this thing.
Yeah.
It's basically going to take, it's something like one of the Packlet build system things where you take a directory and do something with it.
But why don't we just do get or needs in a profiling environment and have this happen seamlessly? Isn't that what we do?
Yeah, like I want to stress that this is kind of just a hack.
Okay, so you don't want to keep, wait a minute, you don't want to keep a copy of the profile annotated source. You don't care. You had to do it on the fly. It took a long time here. I wouldn't, on the grounds that you need to do it on the fly because you will have changed your code or something, or what?
Yeah, the implication is that you are also modifying this based on, reports, and you have this loop, this development loop going.
Okay, but a better thing to do would be to use some kind of hashing to determine for all the files there, did any of them actually change? Don't bother to rebuild the profiling.
Sure. Yeah.
What takes the time? Is it writing it out? It might be.
It's not writing it out. It's processing big chunks of code.
Well, the kernel loads all of his code pretty quick, actually.
Okay, no, it's not his code. It's going through and annotating all the code. Okay, let's assume that takes time.
I think Tom's question is a fair one. It's not 100% obvious to me what consumes the time.
I need to profile the profiler.
Yeah, sure. It's much neater if you can just always do it if it's cheapish.
Yeah.
I don't think that's going to work. But look, the bottom line is you want to be able to say profile evaluate anywhere and have that just work. So in other words, you could basically say when you say get, when you do the get on to load in the definitions from those files, have it be the case that you can do get, a profile version of get that will automatically store all the profiling material.
Yeah.
However that's done, whether it's a separate file or it's done on the fly, who knows? As long as it works and it's fast.
So maybe it's profile get or profile needs or something like that. Yeah.
Well, yeah, I think.
Okay, all right. Let's move on to the next segment of the meeting. Okay, I think we've got the understanding. So data set is what we need to see for the output of this, and the tools of what are the what are the ways to make higher level things. I would suggest function repository functions that operate on that data set that do a variety of things that people might find useful in terms of making histograms, picking top functions, making pie charts, things like that.
Good idea.
And then we'll make a collection of those things, and maybe they will become more mainstream later. Okay, coverage tests.
Right. Okay. So code coverage, very similar to profiling. Not going to go.
Can it use the same? Can it use the same annotation information or not?
They call different functions. If things were abstracted, maybe it could use the same information. Yeah.
Well, so wait a minute, but so you have to make a decision. I'm going to profile or I'm going to do coverage. Is that correct?
Correct. Right now, yeah. It's
okay. All right.
It's a separate function. Yeah.
Well, that seems wrong, but unless it has some desperate reason for having to work that way.
Well, it's different information. profiling. Yeah. I mean, so.
Okay, so let's see the coverage report there.
So for people that are not familiar, this is very standard LCOV coverage report generation that's tied into this so that we can see this. So the result is
for us, we should be able to make a graph. That is, we should a graph as in a thing with flows in the graph. I mean, this is something where it is trying to make the thing as a sort of spreadsheet, right? But for us, a function calls a function calls a function. We're basically getting path weights down a graph, right?
Yeah, that's another way of visualizing. Yeah.
Right, and that will be very, very useful and much less confusing in many ways than something like this.
And something with graphs, you can basically treat as like a heat map of, how many times a function is called and different colors, and it's all very nice too. Yeah. So,
well, I mean, it's a little complicated because if F calls G and F calls and H calls G, there's a question of, the different ways that you might present that graph.
Yeah.
Or recursion as well.
Yes, recursion is another case. But still, I think it's a thing we can do that is beyond the kind of spreadsheet-like form. But why don't you show what you can do right now?
Yeah, so I mean, this is just the result. And so you click through to the file numeric. I don't know why I just clicked on that. It's not.
So wait a minute. You are generating a .lcov file or something. Is that right?
Yep.
I see, which is then exported to some other tool.
Yeah, so you could run the lcov command and gen HTML and do all of this. And I think it would be nice to even just have this even representation in a notebook also.
Sure. But it's nice. It's nice to interoperate with these kinds of tools. So,
yeah.
You are writing out the raw data for LCOV. So, for example, in the import system, we could have something which reads an LCOV file and generates whatever stuff it should generate from it.
Yep.
Which we could do.
Do we already support like import export for LCOV?
No, I've never heard of that.
I don't believe we do now.
Yeah, okay.
So that would seem very useful to begin with, right? So then an import element could be make the graph, make the spreadsheet, etc.
Yep.
Okay, fine. So you would say coverage evaluated. Go back to your other screen.
Yep.
Oh, somebody's asking what coverage means. It means whether lines of code have been executed when you run a function.
Brenton, you should have run the test suite in that.
I've done it before. I definitely don't want to do that interactively, but yes.
And just to add what Stephen said for people listening, under the theory that lines of code that you've never executed are more likely to have bugs in them because you've never seen what the code actually did.
And you want to run your test suite so that you know that you're reaching all your code in tests.
Right. And so how does this work with verification test? In other words, our testing framework.
That's what I mean. You would run in that. You would run.
No, I know, but one would like to be able to in that testing report have something which gives coverage.
Yeah, that would be inverted from what's currently possible. But yeah.
Yes, that would be that would make sense.
Yep.
Okay. So what decisions do we need to make here? I mean, this looks like there's a question of how we make this just-in-time creation of profiling and coverage tagging information, which I think is necessary, so that coverage evaluate and profile evaluate can just work. Right?
Yeah.
Well, hang on, wait. It's more complicated because you need to know what the source code is. You see, in coverage evaluate, you're just doing an evaluation, but you don't know what do you have.
No. We just went through that, Tom. We've got two cases. We've got the case where you have a bunch of files where the thing has to be pre-tagged with some kind of special version of get when it's read in. Case number one. Case number two, which we have not properly addressed, is what to do with cell IDs in a notebook. Okay. Case number three is pure disembodied code. Okay, where we expect to either
but coverage is trickier for pure disembodied code because you have to define the universe of the code.
Yeah.
Right. Why isn't coverage by function?
You could do by head, that appears in the code.
That's what I would do. Right. I mean,
but it becomes a little bit. It does become a bit lexical though, because of course, if I'm calling some system function, I don't care what fraction of the coverage of that system function I'm getting, right?
Well, it's only relevant to the down values of user code.
Yeah, exactly.
Right. That's what it should do. It should report coverage by, I mean, in a perfect world, it would report coverage by down value of, so if f has 7 different down values, f of 1 is separate from f of 0, is separate from f of x blank, etc. It's got to be able to report coverage for each of those down values.
Yeah, well, that's feasible.
Fine.
Yep.
Okay. All right. Let's take the very end of your meeting, and then we're going to switch over to the different topic.
Yeah. So that was code instrumentation, where things are at. And really, I just wanted to show you what's on GitHub right now. I don't know if you've seen
here. Right. This is good.
So for CodeTools, Code Parser and Code Inspector are repos that are up on GitHub right now. I'm pleased to see that they're very popular, starred repos. A lot of people like it so far.
Good. And what do they do? What do these do?
This is the AST this is the linter.
Okay. All the merrier. Yeah.
So one nice thing is that I've hooked up with the parser is GitHub Actions, where when we push up any changes to code to GitHub, it actually goes about downloading Wolfram Engine, installing it, activating it, building the code that I just pushed up, installing the code, and then running all of the tests, to verify that everything was fine. So this is an automatic thing, for example, that can just run by virtue of, GitHub's API, GitHub's actions that they've allowed people to extend and plug into. So this is just a thing that just kind of works on GitHub, and we can just use it and see the results whenever any changes are pushed up, and anyone can do this. And so
wait. If I have a piece of Wolfram language code and I'm storing it on GitHub, and I want to do what?
You want to run verification tests on it.
Okay.
And you want to build, you might have C code you want to build and things like that.
You have some test suite of some kind already.
Okay.
Yeah, this is really cool. I mean, this is a standard thing that you have on GitHub, is you have these actions, and you can have an action that's like, run the tests, and then it'll report back coverage.
Yeah.
And
it's like what? Yeah.
And as a for example, in the way in which it's used, if somebody submits, contributes a pull request, you want to be able to run all of the standardized tests on that pull request before you spend a lot of time reviewing it.
Yeah.
So whose computer is this running on?
Some Azure cloud thing in Microsoft.
Okay, fine. Okay, but it's running from
who's paying for it? Like, how does that work?
You can upload an artifact to GitHub that has your report plus the build. Yeah, that's true. Yep, that's a good point. This is all free.
So I mean, it's GitHub. Like, GitHub is saying, like, oh, you give a job to GitHub and GitHub will run it. And the job you've given it is to install Mathematica and run all this stuff. And basically, GitHub is running it for free.
No one's complained about any bandwidth or anything yet.
Okay. Well,
I mean, there's a completely separate discussion going on, which isn't appropriate for this meeting, but which you should plug into, Brenton. Okay. Make sure. I mean, John, you can perhaps connect Brenton to the other discussion with GitHub.
Yeah.
Okay. Okay. Well, that's cool. I mean, I'm not sure I fully understand this, but
it's very useful. I mean, this is really cool, I think.
But so, what is this? This is like a Makefile or a Jenkins job or a whatever, or Puppet, whatever these things are called. I mean, it's a thing which is running. What specifies? What's the source of the actions that are being specified here?
This YAML script.
Okay, fine.
That is in a special location.
Yeah. Okay. So it's a YAML script that runs against that is running essentially on the GitHub infrastructure as to do these actions.
Yep.
Okay, it's cool. Very nice. It's very nice.
And
Well,
so
I don't understand how it.
and so the key thing most of it is just kind of set up to get, Wolfram engine up and running, but the key thing would be right at the bottom, which is now, we have some actual tests here that we want to run, and we want to ensure that those tests ran successfully.
And all that this is just running the actual, this is an actual WLS file. So
Nice. Very nice.
so
Okay, so next time, Brenton, we need to see all the code formatting stuff, and also need to talk more about the integration of code assistance with the front end and with the cloud. I'm not sure we've live streamed any of those things. People would, I think, find that pretty interesting. So hopefully we'll live stream the next discussion about that. All right, I think it's time to switch to a different topic. So Christopher, are you going to share, or did you send me something to share?
I should probably share, because you'd have to install Packlet right now. I don't think it's in a place where you can easily install
Okay,
it.
great.
So
okay, well, let's just give a basic intro to what this is all about, because we had a bunch of other people join.
Yes.
So this is about what I'm calling code robustification, but it's about mechanisms for handling errors and exceptions in code. Okay.
Yes. With the main focus right now being on larger pieces of code, but yeah. So we had a previous meeting about this. So I'll sort of summarize the basic design right now. So the basic setup is that there are quotes two functions. There's basically a function called enclose and a function called confirm, although there are many different types of confirm. And the basic idea is that enclose is a bit like catch and confirm is a bit like throw. And so you put enclose around sort of a big block of code, and then you put confirms in the middle of it. And the confirms are kind of like asserts that will assert that, nothing has failed and nothing is missing and stuff like that, in places where there shouldn't be failed and missing things. And then if a confirm is sort of triggered, then it will throw a failure up to the enclose, which can then handle the failure and return something. So, a very basic example, right? So I've got
those are nicer names, by the way, much nicer than last time.
Yeah, I mean, if you have other name suggestions, then we can. I mean, these I think are the better names.
I can't remember what the last names were, but these
they're okay. I think
I remember one of them was guard.
Yeah, I think it was contain and guard. This is better. So there are kind of two main things I think we should talk about, which is types of confirms and some of the detailed behavior of enclose. So first, just to give a basic example, right? So basically, if the basic confirm just checks for failure queue and missing queue right now, it might also check for messages, but that's what it does right now. And if it doesn't trigger, if a confirm doesn't trigger, it just lets the stuff flow through it like echo or something like that. And then if it does trigger, it will throw a failure object up to the enclose, which can optionally handle it and return something, or it can just return the failure object by default. So that's the basic behavior. So let me see. So maybe the first thing we should talk about is like the details of how enclose works, because there's some complicated semantics that came out of last meeting. So one of the features of enclose right now is that if you give it a tag, it will be quotes dynamic, like throw and catch. But if you don't give it a tag, it will be lexical. So like for example, right here, if I define function here, right, and I run this, it will fail. Ignore this, but it will fail because the confirm doesn't see the enclose around it because it was not lexically inside of it. But if you give it a tag and then run it, then that has no problem, and it works like throw and catch. So
I think you're going too fast for people. Okay.
Okay.
Do people understand this issue? This is a very tricky issue.
I understand the issue. I mean, I'm a little bit concerned about the fact that this feels a little bit like, I mean, I suppose the fact that it's strictly lexical is perhaps a saving grace, right? But the fact that there was no catch that could catch all throws, has long been an issue.
Well, actually, this is another thing that we were talking about and that I was sort of proposing as a change to throw, which is that I think throw should get a third argument analogous to the third argument of like time constrained, which is like evaluated and returned if there is no catch. Right, so time constrained has a fail expr, which is evaluated and you know, if, well, there's no such thing as a catch for time constrained, but you get what I'm saying? So right now throw only has 2 arguments, but you could just give it a third argument, which is the fail expr.
Right on a live stream is asking about how this differs from check and throw and catch and so on. The whole point is to make streamlined code that doesn't have to change its control flow to deal with throw and catch.
Right. So I mean, the usual thing you do with throw and catch is if I want to, you know, run some piece of code and I want to check if it worked, I use a module or something. I save the piece of, you know, the output of that code in a variable, and I say if missing q of x, then throw, etc. And so you have to, you know, you have to sort of change the whole structure of your code. So the goal is to, you know, let you do this without changing the structure of your code.
Right, and the point is it's not the same as assert, because confirm, if it confirms correctly, it just evaluates to whatever that value was. Confirm only does something if the confirmation fails.
Confirm and catch
confirm
and throw are kind of like echo and print. You know, it's analogous.
I mean, confirm breaks out of the control flow that you're in.
That's correct. If the confirmation fails, then it breaks the control flow.
Right. So you don't even visit those other parts with bad data. But I was wondering, there's a question of so that's sort of triggering and failing gracefully. Is there a sort of recovery? Does enclose have recovery? Can you do?
Yes. Yeah.
Okay.
So there are 2 pieces of recovery. So the first thing is that confirm, all the confirms have kind of they have different argument structures, but they all have a second argument, you know, which right now is just called info. But basically, you know, if I put something here, I can say, you know, what type of failure it was. So I can say, you know, it was failed, right? And then in the failure object that gets thrown, that information is communicated. So basically, you can communicate which confirm did this error come from, and then encloses second argument is a function that gets applied to the failure object. Applied to the failure object if a failure is thrown, right? So this can be the handler function. So for example, here I could just, you know, this would be a simple thing to do, right? Where it just, you know, returns this field and so on. All right, so at Sentinel, this is the handling function, and this is how you communicate extra information about where the failure was.
Yeah, I'm not sure we necessarily want to get derailed by this, but this proposed third argument for throw, I guess, at what point are you thinking it will, like, if we, like, basically the out, well, if you get all the way to the main loop and you still have an active throw, then you replace it with this third argument?
I think so. Yeah, I mean, I think it's right. There's this, I mean, there's like this function I think called catch everything, which is how this is implemented. Mm-hmm. And right now it throws a message, and I think alternatively it can, you know, it throws a message and returns the held throw. So I think if it sees a 3 argument throw, then it could just return evaluate and return the third argument. The only like
argument could be a function applied, then you could use the same one in many places. It could be a function that gets applied to the payload of the confirm.
The throw or
the throw? We're talking about the throw.
Throw. Okay. So I mean, right. So one question is, right, I mean, you could make it an F, and then it gets you run basically F of value here, right? That's what you're saying. I mean, the only thing about that is you kind of know what the value is because you called the throw.
Yeah, but you know, that means every confirm you have to rewrite with a special, you know, special thing.
I'm not sure.
We're not talking about confirm. We're talking about throw. Tom,
you were talking about an argument to
throw.
To throw.
Okay, whatever. You still, if it's a function, you can use the same function in many places, in many throws.
Right. let's not get derailed with this. Let's go back to confirm, because I think there's a couple of fairly important points that have not been. I mean, we should talk about the different kinds of confirm, but also the really important point is how do confirm and enclose are a pair, and a confirm has to find its appropriately matching enclose. And the question is, how does it do that?
Right.
Because
the fact that the second argument changes it from lexical to dynamic is weird, I think.
Yeah, it is weird.
It's weird.
I think it should be one or the other.
It's clever.
Well, but so, I mean, here's the problem.
Yeah.
I mean, the problem is, right? So first of all, there's a problem, I think, with throw and catch if you use them in the default way, which we discussed last time, which is that basically you need to use a tag if you're doing anything serious, because otherwise, you can catch user throws and stuff like that. And so, at some level, so the advantage of the lexical version is that it avoids using tags and it's still sort of safe, right? And I think that basically 90% of cases should be done with the lexical version. And that basically for problems like, oh, I have this, I have a function which calls another function and the inner function might return a failure, then I think you just want to have 2 layers of enclose. And if you're just using confirm and stuff like that, it's easy to propagate those errors up. And so you can sort of do it all lexically. But then, and so I think that will be 90% of cases. And then the only reason for supporting the tag version would just be because there are probably a few cases like with nested encloses where you sort of really need to be able to specify that.
I think it's the same thing as with module and block. Most of the time you can use module, but occasionally you need to use block.
But those are 2 different functions. So why not have a confirm and a lexical confirm, or a confirm and dynamic confirm if we think the lexical version is the more common one? Certainly, I would be more likely to use a lexical version than a dynamic version. But I know there are others in this meeting who would disagree with me, or whose coding patterns are different than mine.
Right. Can I just, right. That's totally reasonably timed. Can I just make, first of all, the message version of confirm, the actual message might be generated deep down in something else. So that's kind of dynamic. That's not very lexical.
That's true.
Maybe we should talk about that. Should we talk about the types of confirm?
And another point, which was, Christopher, I know I looked at this. How are you implementing the lexical enclose and confirm? How's that implemented?
I mean, these are sort of prototype implementations, but the way I'm doing the dynamic one is being done with throw and catch. The lexical one is done by basically it makes a module, then it defines it generates a UUID as a tag, and then it makes like a thing called local confirm by, etc. It makes local versions of all the confirms. It replaces it would replace all the confirms with local confirms, then it replaces them back when it's done.
Right. It would be kind of nice if the lexical confirm didn't need an enclose. It just confirmed out to the enclosing function.
Right, like return, basically.
Like return should be.
Yeah, I mean, the only thing, like, we talked about this, I think, briefly last meeting, but I think it's just that the semantics of return are too weird.
Well, but we could have, this is a new function. It could have new semantics that were well defined, not weird.
Well, sure. I mean, but there are also cases where you want like lexical, where I think you want lexical, with an enclose, right? So I've got some examples here, like,
that's fine. Maybe you could nest. You mean you have enclose inside enclose? You mean?
No, Tom, you were suggesting something, which is, can you have a naked confirm in a function where when you type confirm, it is some kind of within that function confirm that resolves itself with an implied enclose at the exterior of that function rather than propagating further.
That's exactly what I was asking, yes.
Right, so it's got a function level confirm.
Yeah.
That's a possibility. Mm-hmm. Maybe you should show some more examples, Christopher.
Yeah.
And then talk about the different kinds of confirm.
Yeah. So I mean, here's some. I mean, I don't know. So the basic. Here's some basic examples. So for example, here, right, you can run this. You can use confirm match, which you give a pattern, and it will check if it matches that pattern. And so in this case, it ran it. And in this case, if I do sign of x, where it won't actually evaluate, then it will. In this case, it will throw failure. Then there's also that, and then there's also the second argument of enclose, which lets you do error handling. So I think this is sort of a nice real world example. So right, if we use entity value and we get GDPs and populations, one thing you might want to do is if you get the GDP per capita and maybe the quantity magnitude of that, this is kind of the natural code you would write, but you get this sort of garbage in it. And so as an alternative, here's sort of another way of doing it, where you map over these, you confirm that basically the two pieces were not missing or failed, and then you get the quantity magnitude. And then critically, you wrap enclose around the inside of that pure function. So it's just going to enclose it at each step. It's not going to enclose the entire evaluation. And if that particular step failed, it will just return missing. And so if you run this, you get a sort of much cleaner output.
I think it's worth talking through this piece of code because this is an interesting example, right? Because what you need to do if you don't have enclose and confirm is pretty messy. You have to have a bunch of ifs there.
Would it make sense to have a level spec for confirm so you can specify you don't want missing or failed anywhere in the expression?
Yeah, so I mean, in an earlier version of confirm, there was a level spec, but it turns out, I mean, here's the thing. The first point is that you can map confirm over an expression, and that works right now. So you can kind of get around the lack of a level spec like that. And then the other thing is that it just became kind of argument clutter because they do actually have a few arguments. And so if you had to specify the level spec every time, I think it would get very long.
The fact that the mapping of confirm works is interesting, and that has to do with the way that the rewrite of confirm into this lexical head thing works, right? I mean, what's happening when you map confirm is it's turning the confirm into this tagged version of confirm.
Yeah, I mean, it has to do something like that. I mean, that's what it's doing right now. But
could you show the enclose outside of the map, around the whole map, Christopher?
Right. Yeah, that's a good point. So if I put the enclose around the whole thing, and I'll also make it, I'll give it the same function, then the whole thing will be missing, right? Because basically, here it's like catch. So it goes out to the the enclose encloses the entire function, the whole thing returns missing.
And the evaluation stops when the first confirm gets a failure, right?
Yes, like throw.
But what made that into a dynamic confirm?
Well, this is lexical, right? Because look, the confirm appears lexically inside of the enclose.
Well, it sort of reached through.
No, it didn't reach anywhere.
I mean, in the same way that module is lexical, right? These are green. Even though yes, you're right. I mean, it's not, it has to look inside the code in some sense, but yeah.
Right. I mean, I will not discount this as, sort of a valid coding style, but at least to me, this particular example, it would be more natural to use delete missing first to delete the entries with missing and then just map the divide across.
Well, but you want to keep the missing values as missing, for example.
They correspond to other things. You break the association.
Right. And if you put a hash inside the missing and use a second argument confirm, you could say missing no people, missing no money sort of thing, right?
Sure. Yeah, that's true.
Which would be nice too.
There's no enclose and confirm.
There's no sorry.
Can you just evaluate this without enclose and confirm?
Sure. Yeah. Let me wait. Where's the version? Here's the version that works. Let me make a new notebook. So this isn't. So there's no enclose, and then you get stuff like this.
Right.
So by the way, I mean, just to go over that the example, I forget who said it. But if you want to say missing no people, missing no whatever, then you can use the information section here. So I can say no GDP, and then here I can say no people, and then for the encloser handle, I can say hash of
Can't you leave that? Can't you just say cache information there without the quotes? Yeah, anyway, okay.
Well, it's a failure object, so I don't know if that works. But yeah, but see, now it says missing no GDP. Looks like it's mostly missing no GDP, but yeah.
Probably because the GDP fires first.
Yes, probably. They're probably all missing together. But
oh yeah,
there was a question on the live stream. So you always need to use switch in a master enclosed to handle multiple types of confirms from various underlying bits of code. I don't think so.
Right, because the point is, all the confirms, they immediately stop everything. So you can never really have two confirms at once. I mean, you can have some sort of, there's a confirm inside of the handler function for the, for the enclosed. You can have stuff like that, but, you can't have two encloses sort of triggering in the same piece of code at once.
Let's talk about the different kinds of confirm. So the main confirm does what? It looks for what inside it?
So right now it just looks for failure queue and missing queue, but it could probably also look for messages.
Right, and it potentially has what
messages, when you say messages, you mean that something triggered a message somewhere in the evaluation, not a result.
Yeah, I mean like an unquieted, I mean the same stuff that like check kind of catches right now.
Right. I mean,
okay,
if we're going to nitpick, I'd say dollar canceled, dollar aborted sort of should be in there too.
So
okay, yeah, that's a
good. Dollar canceled is a good one for sure. And then Truth on our live stream is asking, won't the nested enclosed be confusing so you don't know which confirm belongs to which? So I believe that it does not get confusing, but can you comment on that?
Yeah, I mean, so if you're using tags, then it's the same semantics as throw and catch, which I believe is the inner one gets used. And if it's lexical, then it's also the inner one gets used. So yeah, it's the same as like throw and catch. But I mean, arguably, I don't know, maybe it could turn red or something, but I don't know if that would be necessary. I mean, that's like what module does.
There.
One suggestion, this concept of info in the second argument of confirm, why not having there the full object that you are returning? So, I mean, if you want to return a failure object, you put there a failure object. I mean, if you want to return $failed, you put there $failed. So I don't understand why this info goes into a failure object, and then the handling function has to start by extracting from a failure object. Could take the
okay, yeah. So basically what you're saying is that you could have it so that the failure object gets processed at the level of confirm, or you could have it so the failure object gets processed at the level of the enclose, right?
The reason to have confirm generically throw a failure object is for nested enclose handling, right?
Well, that's true, but I don't think that's what Jose is talking about. Jose, I think, was talking about, if I'm understanding you, that basically, right, there's the second argument info. And right now, at the confirm level, all you can do is pack stuff into this failure object that's being inevitably thrown up to the enclose. And then if you want to turn that failure object into something more beautiful, then you have to do that at the enclose level. And the question is, why don't you do that at the confirm level?
Exactly. Yeah, just put whatever you want. And it's a bit like first with the default element. If something goes wrong, just put here immediately what you want instead.
Well, so now, so here's a question though. So for example, I think more often, so I think pretty often you want to be able to control from the enclose what happens on a failure, more often than you want to control it on a confirm, right? So in this case, in this example, it was definitely, you kind of want to control it at the confirm level. But I think more often if you have a big piece of code and it's got lots of confirms in it, and the confirms, they're different confirms, they're doing different things, and you don't really want to annotate each one. But you do want it so that, if a confirm is triggered, then the enclosed will be given a failure object, and maybe who knows what this function returns. So it's got to process that failure object in some way, right? And you don't want to put that processing code in every single confirm. Does that make like?
Right. Yeah. What I would suggest is confirm #1, missing no GDP.
Right. But then the thing is what about the case of, so consider this case though. This is not a much better case, but in this case where I just want it to be missing no matter how it was missing, right? I don't want to annotate it. So the point is I could have a really big piece of code that, you know, does all sorts of complicated stuff, and it can fail in all sorts of different ways, and all sorts of different confirms can be triggered. And I don't really want, you know, and maybe I have a single way that's processed at the end, right? Like if any failure is thrown, for example, return unevaluated. That's an example that like some internal functions use. And so you don't want to have to try and specify, you know, kind of return unevaluated inside of each confirm. You want to do that at the top.
But you can, sorry.
Yeah, well, I guess I want to make 2 points. One is, I mean, these aren't necessarily incompatible, right? If there's right, you could have a function of what to do with the resultant enclose, and, you know, the confirm could, you know, send whatever it wants to be eaten by that function. But
that's what exists right now, right?
No. What exists right now is that it throws a failure object that you can apply a function to, and you can add a field to that failure object. But I want to push back a little bit on the idea that this is similar to the second argument of first, because that's you providing how to proceed, and this is a matter of how to stop. Right here, you're providing information on what went wrong, and you're stopping, as opposed to saying no, just do this and continue anyway.
Sorry, you're talking about the second argument of first. Do you mean like the right? I mean, I think
right.
Okay,
so Jose made the analogy
Yeah.
between the second argument of confirm and the second argument of first, and I am pushing back on that analogy, because when you give first a second argument, you're telling it, well, pretend that this didn't happen and just pretend no errors happened, use this value and continue on your merry way. Whereas here you're actually stopping the processing and you're sending information about what went wrong. So it's, you know, I don't think that they're necessarily super analogous.
So the difference is that here we have additionally a handling function, which with the value identity would be the situation I was.
Right. So, I mean, okay, so look, I think we should pin that particular issue of I agree that there's a thing to discuss here of what is, how much of what is finally to be returned is defined by the confirm versus by the enclose. It seems like a good issue to discuss. There's a comment on our live stream which I don't fully understand from Ethan here, saying he doesn't want to keep rewriting confirm. I'm not quite sure I understand this, but I think one of the implications of what he's saying is maybe there should be some kind of enclose that expects auto confirms, as in, for example, you could imagine an enclose. Maybe this is a bad idea. Maybe this is trivial, in fact. Yes, I'm sorry, this is trivial. This is I was going to suggest enclose of confirm quiet. In other words, well, we should go.
Yeah, well, I mean, this is right. I mean, unfortunately, this is actually a quote somewhat useful construct, because basically this is the thing that check should be. But
well,
there are
maybe
also
there
other
should be a thing called
versions of
enclosed
check.
quiet or something, which does that. But let's go through the other types of confirms, because I think that will help in explaining how this might be used.
And there are probably also other confirms that people will know about that should exist. So okay, so the confirms that exist right now is there's the basic confirm, which, you know, this is like a heuristic one that's should just you know get most cases, but it will miss a bunch. Then there are the sort of more, you know, specific ones. So there's confirm by. So this one, you basically give it a function, and if it doesn't return true q, or if true q of f of expr isn't true, then, you know, it will fail. So this would be something like, you know, if I had an enclose of f of confirm by, you know, region intersection of who knows what, you know, confirm that this is a region, right? That would be an example. Right. Then there's confirm match, which is the exactly analogous thing, but it takes a pattern. You know, this is not exactly the same, but yeah. And then there's, confirm quiet, which checks for messages and which should have an argument, a sort of a second argument that's analogous to the argument for check, where you can specify which messages you want to kind of catch. And then the final one is confirm assert, which is the slightly different in that it doesn't have this kind of echo-like property, like it doesn't pass through things. It's just given a test, and it's just like assert, except it will throw a failure to the enclose. So this is actually, exactly the same as, this is the same as this basically, except that it will probably include slightly different things in the failure object it throws.
Do people understand these? So, okay, let's talk about confirm quiet for a minute, because I think confirm quiet is a little bit more complicated than you're letting on.
Okay.
I mean, confirm quiet is the only one of these that reaches execution-wise into everything that's inside it. Everything else just looks at the surface, right? Confirm,
Yes.
confirm type, confirm match. They all just look at what is being returned to them. They inspect it, and they confirm that it has some particular form. Confirm quiet, does it throw immediately that the message is generated? Or does it wait until the rest of the thing is executed?
It throws immediately, unlike check.
I see.
And I should also mention, so here's an example. It actually does not throw the message. It only throws the message here because of a bug with text string, which is used by failure, which is why this is an infinity and not 1/0. But yeah, so it does actually catch the message, but yeah.
But it doesn't, in fact, quiet the message. That you would do separately.
No, it does quiet the message, is what I'm saying. So if I run it, see if I'm running it right now, it quiets the message. The only time the message comes up is because in displaying the failure object,
I get it. I get it.
And it runs it. Yeah.
Yep. Okay.
Right,
So,
and just add a semicolon print of foo after the confirm quiet, just to prove that it really is.
Right.
Yeah.
Yeah.
Put the print inside the confirm quiet after. Yeah, put it there.
I mean, it doesn't, right. So this is the weird thing about confirm quiet, is at some level it doesn't matter, right? Yeah, I could put the brackets here and it would be the same.
Right. Yep.
But yeah. Oh, no, it's
why did it do that?
That doesn't seem right.
I don't immediately understand that. Okay. Well, I should look at this. I would expect that not to return, not to print foo.
Right. I mean, because it's showing check-like behavior as opposed to.
Yeah, it should not show check-like behavior.
The
Probably. I mean, check. Well, I mean, right. The thing about check that makes it kind of frustrating is that, right, normally you just have a long piece of code and you just say, oh, it's hopeless if it throws a message, and just stop. So yeah, that's probably what this should do.
Okay, let's talk about message buckets.
Check.
Which is, the question is, are all messages created equal? Answer, obviously no. Some messages are more concerning than others. The question is, can we meaningfully define message buckets? We have a partial effort at defining message buckets from long, long ago. What version was message groups added in?
6.
7. But yes.
7.
It's probably not been well maintained, but I don't think that the message groups thing is the right kind of bucketing for confirm quiet, because I think what you want for confirm quiet is, I mean, okay, there's several points here. One is this whole question about, things returning unevaluated. Oh, we want to know that things returned unevaluated because they're not supposed to. The semantics of quotes return unevaluated seems completely messy. And it seems better to push people to use confirm match and confirm by to define what they mean by quotes unevaluated.
Well, okay, right. So this is this is another discussion, which is whether there should be
All right. I was going to say, I mean, if the input is same queue to the output, that is probably an error that should be caught by just plain confirm. Because
what about 2 or 5?
Right, but why would you write confirm around 2?
Well, right. I mean, right. Assuming that it's hold first.
Yeah.
Assuming it's hold first, but I mean, but no. This is the problem with that, is that then it means that if I have right. So for example, let's say I have a list of things, right, and I want to say confirm /at, or maybe I'm saying f of confirm. Who knows what, but I'm running this, right? You see where this is going? So,
yeah.
Right. So the point is that by the time this is equivalent to this, and by the time it gets inserted here, you know, just to demonstrate.
Right.
Right.
Or there's a with outside it that's injecting things that you don't know what they are.
Right. Exactly.
Mm-hmm.
Well,
so this is a reason why. So I mean, one of the things that we talked about last time, but not for very long, was the idea of some sort of confirm evaluates or confirm changes or something like that, which would basically be this, but for this reason, and because of things like 2 plus x and x plus 2 give different results, right. You know, there's some weird properties of such a function.
What about combining these? Does confirm match also do confirm?
No, confirm match just does match.
So if you wanted to do both things.
Oh, well, you could say confirm of confirm match.
I mean, obviously you could set up a pattern for confirm match, but you understand what I'm saying.
No, you just do that. You want to do them both, you just
right. Yeah, you have to do that. But, yeah, you have to have this stack of confirms.
Christopher, when you have things that evaluate themselves, are you worried? What are you worried about? Is it down values that don't trigger?
Sorry, what do you mean for? You mean for?
We should have. Yeah. Is it down values that don't trigger? Or is it
no? He's worried about the fact that he might be mapping confirm a bunch of across a bunch of things, some of which evaluate non-trivially, and others, like 2, do not.
No. Wait.
No, he's talking about. So I mean, the case we're talking about, right, is that there's some functions like, you know, like that example with integrate, right, where this decided to return unevaluated, and there are times when you consider that a failure. I mean, like maybe not for this integrate case, but there are other examples where functions return unevaluated when they fail.
So what?
Right. So plot of x comma x.
There you go. Perfect. Yeah. So I mean, so I would actually argue, you know, okay, so the kind of hacky way that I think most people deal with this right now is they check if the head changes. But I think that this is actually the correct thing to do, because, well, this is pretty much the correct thing to do, because I think that the head changing, you know, if the head changes, it means that it's actually, you know, evaluated in a non-trivial way. And if the head doesn't change, that means that at best it evaluated in a trivial way by, you know, maybe it turned into some other case of itself. That makes sense.
So in this case, what you would do here is you would say confirm match of plot x comma underscore graphics.
Or perhaps no, not necessarily. Except plot, because plot doesn't necessarily return a graphics.
What does it return?
It can return legended.
Yeah. So this is right. So I mean, the question is, at some level, I think if there would be a function that's kind of the check if it was unevaluated function, I would actually argue it should check if the head changed.
So it's just check changed in some sense.
Right. I mean, because this deals with the case of 2 plus x versus x plus 2, and it deals with a bunch of cases like that. Now it is missing some cases, like for example.
So I mean, one thing that's very distinctly different. So I agree with the case that you gave. That's really a true failure case. The integrate, you can still do a bunch of things on it. You can differentiate it. You can asymptotically develop it. You can do, you know, there's a bunch of other things that you can do. So that acts as an actual sort of model that you don't want to have to kind of type in again. If that was a definite integrate, you could numerically integrate it and so on.
So I mean, you mean just that you know, there are some cases where things return unevaluated, but that's still useful. Is that kind of
yes, that's what I'm saying, because they are effectively models, and we have actually, you know, large and growing workflows that rely on that. You know, that so we have a bunch of functions that are active, they try to do something, but they can also be inactive, you know, either unevaluated or explicitly inactive, where they represent something that you can informally manipulate.
No,
and
right,
regions is another good example. Like those disks, the disk itself is a model of a disk, you know, and if you have a parameter there, there's like a whole family of them, and you want to be able to actually deal with that whole family of disks.
Right. I mean, exactly. I mean, that's why, right. So I mean, the thing is, though, is that this is why, I mean, it's an optional thing, right? There's some cases where, for example, that region intersection I ran, this is a particularly hard case because the head does actually change, right? There are some cases where
but there's a bunch of other in probability and statistics, like so these what's called derived. So these are derived regions. They're new regions from old regions. We also have derived distributions, new distributions from old distributions. So transform distribution often return unevaluated, but
But
it
the PDF
acts
you
as,
can still get and stuff like
you
that.
can get
right.
the PDF, you can generate random numbers, you can do everything like you could do with a distribution.
Right, of course, right. I mean, so the point is, this is the thing about returning unevaluated, is that sometimes, like in the case of plot of x comma x, returning unevaluated is a failure mode.
Exactly.
Right, where it's nothing matched. But there are also cases where it's really not a failure mode, or where it's a I mean, in the case of, you know, transform region or something like that, I mean, I would kind of argue it's a weird, well, transform region is a particularly hard case, but in many of these, I would argue it's actually kind of a weird, like, pseudo failure. It's like I don't have enough information yet to turn into something meaningful, but if you give me an R in this example of the region intersection, then I can actually turn into a, you know, something else. But
no, I mean, we
yeah,
happily work with, I mean, by design, we intend to work with these sort of parametric regions.
Yeah.
You know,
right. I mean,
so that's not a failure. It's an advantage. But you know what one could do, I mean, but I think that if we can bucket, but I've seen many functions that come out and now return unevaluated, and there's nothing meaningful you can do. And I kind of would like to prune them out, because it pollutes the meaning of unevaluated being useful.
Yeah.
Example.
Yeah, I mean, well, there's some edge cases though. I mean, so here's an example that I think you even brought up last time, which is part, right? And then now it's indexed, right? Where you like part being able to be unevaluated, except you're mad at the message, right? But index gets around this. So I mean, that's an example though where, even though in some, you know, in most contexts, part returning unevaluated is, you know, a catastrophic failure. It's like something's gone horribly wrong. But there are, in principle, times where you might like to have it unevaluated.
Yeah. And if we can more clearly define those cases, and sort of, you know, some one level of bucketing and saying that this should rather go to sort of failed. Like if you do file operation, they basically return failed. They don't sort of stay unevaluated if it can't do its thing.
Yeah.
Well, I would say most file operations, if you give it something that's structurally invalid, they returns something, they return unevaluated. But if you give it something where where it's not possible to do, then it, you know, returns, a dollar failed or some equivalent failure type thing.
So Ethan on our live stream is complaining that the confirm functions are symptomatic of the root problem that message is ancient and needs an overhaul. I don't think that's quite correct. I mean, I don't disagree that message is ancient and needs overhaul, but I think there's more to. I mean, there's plenty of things like missing that is perfectly valid symbolic thing to deal with that is not a message type failure type thing, but nevertheless is convenient to be able to handle programmatically. And this is part of the story of doing that, I think. But I think
I agree. I mean, I think the thing is that it is true that in many ways messages are a little bit, you know, in need of overhaul. But I think that the problem with messages is that
messages are for humans.
Right, messages are for humans, and they're hard to categorize because they, you know, and they're not categorized for that reason. And you know, some messages are catastrophic, and others are just like, you know, a little, you know, just so you know. And so
it's context dependent.
Yeah, exactly.
Yeah. No, I told you I tried to sort of basically split them in two, errors and warnings, and it just sort of gave up after a while. But
so the question for us here is confirm quiet. Does it have buckets of messages? I think it will be useful if it did. That is, confirm quiet, say there are no structural error messages, let's say, like part things and so on. There could be a such and such a function failed to converge, et cetera, but there are no, you know.
Right. So I would say that confirm quiet and actually check and quiet in general. So check and quiet both take, you know, specific messages, lists of messages, and message groups, and surely confirm quiet should take as well. What would be really nice is if you could use patterns, which are like, you know, log plot : blank, and, you know, blank : you know.
What? That's the problem.
Well,
I mean,
no,
the
no,
problem
no.
is that
No.
I think this
No.
should work. There's no reason
No.
this shouldn't work, right? Just do the check if the pattern matches when a message is thrown. That should absolutely work, I think. I'm actually just check not do that.
the problem is that message, if you look at the syntactic form of a colon message, it's a weird thing. It's not what you think, because it's automatically stringifying the second piece and so on.
Well, it's message name of something, comma, right? Right. So it doesn't. Right. You need to do all. Well, I guess it's that.
is saying that we need a new concept of exception object. We have talked about this, but let's just review that for a second.
I think this is what a failure object is. Like, I mean, I think we can probably spruce up failure objects a bit, because I think they do have some weird properties. But I think failure objects are, if we had an exception object, it would be the failure object.
I agree. That's true.
And there wouldn't be something, I mean, an exception object sounds like it itself is hot to handle, and as soon as it's generated, it starts propagating places. But I don't think we want that particularly, because failure is just a symbolic thing that sits there.
That's correct, but a failure is what should be thrown if there's a throw or a confirm or something.
Right. Yes. I mean, a failure is right. I mean, but this is the. Yeah, I mean, I think this is a syntax question of whether you call it an exception object or a failure object. And I think these are just synonymous. I mean,
all right. So maybe we should return. So we have not addressed this question about buckets of messages.
So how are they
at some level, yeah.
I just think it's going to be important to people to be able to say, I have this piece of code. It's important code, and I want to make sure if something really horrible happened inside it, I want to exit. If something that is a minor quibble happens inside it, because one issue right now is we've got a big agonizing about should a message. So here's a question: if a message is off, does confirm quiet still see it?
No.
That's unfortunate.
Yeah, it should be. Well, I think it should be the same as check. So actually, with check, if a message is off, can you still check for it?
Not unless you unquiet it inside of the check.
That's horrifying. You see, but I think that's a mistake.
Right. Yeah, well, it's almost impossible to do any evaluation without, quieted messages. I mean, do, foobar shift enter. You just generated a message. You don't know it, but you just created a new sim message, which, is what makes debugging bugs in messages so entirely painful, because way more are generated than you ever see.
Okay, so hold on. Let's talk about that for a second, okay? Because this idea of chatty messages which are off by default and being able to handle those programmatically seems to me interesting. That is, that because if we did that, we could have a bunch of advisory things in code which could be picked up by confirm quiet, but which will not bother the poor human user, so to speak.
What's an example
that is I don't think that's practical. I mean, if you gave confirm quiet specific things to look for, fine, but just saying all quieted messages, that's far too many to be even remotely useful.
Fair enough. But then that's why I'm talking about message buckets, because it's to me, and maybe I'm wrong, to me, one of the issues here is you have something that you think is a production piece of code. Okay. If something goes wrong, you want it to respond in some way, like the server can't respond to that request or some such other thing, rather than just disgorging some random piece of internal, state. Okay. But on the other hand, if all that happened was some minor, this numerical integral didn't converge quickly enough, you don't want to abort the whole thing for the sake of that. And I'm just saying, can we characterize that in a fairly general way? When is something, I mean, this is Roger's errors versus warnings, and I understand that's difficult, but what I'm asking is there, okay, do people think this is a relevant or important problem, or do they not?
I think it's a relevant problem. I think it would.
What about messages by areas, like geo messages, numerics messages?
You're talking about a logging system that exists in other systems. I'm not saying we should have that, but that's kind of what you're hinting at.
Well, perhaps it is, yes, in which you log all messages, including the new SIM messages and so on, which are basically noise.
Logging, you have levels of logging, like warning.
But no, I think what would be more useful would be, what Jose was saying is, right. So you could have the internet messages and the geo messages, and which are not maybe necessarily distinct.
Right.
And then, so if you're writing, something that talks to a server, you can enable the internet messages, and then you don't have to worry about, integrate issuing or my favorite example, solve issuing a message that it used inverse function, so the solution set may not be complete. I mean, which is absolutely an important thing to know if you are doing some symbolic computation and you need to know how general your solution is. But if you're connecting to server, you don't care.
Well, so in fact, we probably have in Wolfram language data, we probably have some tagging of that type of area by function, I suspect. And so
there's another thing that we're looking into as well, which is getting even more chatty, which is progress monitoring. And
yeah, but I'm not sure that's an orthogonal axis, I think.
Kind of. I mean, but this discussion here has started to slant into that direction. Some of these warnings are really like super chatty. Like you see here on screen right now, see all these plot functions ACBend messages? They are, they give a warning when the adaptive refinement didn't reach its goal.
What happens when you have a time constraint? What happens to enclose when there's a time constraint inside it?
I think the time constraint will win in some sense. Let me see. Like,
no, you want to say pause.
Yeah, I mean
So
that's another thing.
Very well want the enclose for time constraint. Enclose the abort there.
Yeah, I mean, just as a general. Well, I mean, this is a
general weak
catch-all.
Our exception mechanism that we have all these different balkanization of, sort of exceptions. And I was pleased.
That's what we're trying to deal with here.
Right. I mean, it's very confusing to know why catch.
Right. So let's fix it, Tom. Okay. So let's go back to the.
This is why confirm and enclose. Well, I was pleased to hear that it was using throw and catch.
What should this case do? I mean, should this case, if you say enclose confirm time constraint, what does it do then? Does confirm look for aborted or not?
I think it shouldn't, because it should be the same as throw. Throw can go through anything including enclose, right? I don't think enclose should stop everything.
I think there should be an argument of throw that you can give that's documented and simple that enclose does see, by the way.
What do you mean?
Why?
If you could give it a tag of enclosed.
But there's some sort of whatever. I think we should consider enclose and confirm as sugar on throw and catch in a simple way. That makes it easy to understand what they do.
So you're suggesting that you should be able to throw to an enclosing enclose?
Yeah, I am suggesting that with the appropriate, arguments. That maybe throw of a failure or something. I'm not sure, but
no, we can't do that. That'll break. Well, I suppose won't break anything because there won't be any enclose, but
it doesn't exist, so it can't break anything.
Yeah.
Yeah, it's got to work there.
What about the situation about lexical versus dynamic? So right, because I mean, basically the way enclose works, I mean, the way it implements its lexical stuff is that it secretly always has a tag, right? It just adds the tag lexically when it's not provided.
I think it's okay to consider that as some sort of, I'm not so bothered by that. I'm thinking about the global, the sort of thing that goes up the stack.
So what about this case? What about the case of I've got, some foo, and I've got foo of, this does that, right? And then I've got enclose of, if I have this case. So this is basically the case of, this is the same as the problem that production throw and catch without a tag has, which is that you can catch user throws. So if normal enclose, without a tag, let's say, behaves like catch, and it catches all the throws that appear dynamically inside of it.
I'm not saying it would catch all of them. Put a,
oh, okay.
Write that in terms of confirm. Confirm something.
That won't work because it doesn't have a tag. It's not lexical.
Give it a tag. Yeah.
Sure. So this, right now you have to do like this.
Right. So what I'm saying is it would be quite useful to replace either the confirm or the enclose with a throw or a catch in some simple way.
Don't see why, Tom. I mean, other than
it's very confusing when then we have to have catch wrapped around enclose, wrapped around then it makes it very hard to have simple uniform constructs that catch everything.
But the problem is that the tagging mechanism is different for throw and catch.
I'm saying we
throw
should
and catch
are saying you can unify them. You could unify them. You could give them the same sort of tag space. But so then the question
you mean
is,
using lexical tagging for throw and catch as well?
No. The point is just if you have a tag, if you have an explicit tag, you could make it so that explicit tag is in the same kind of tag space as throw and catch.
Yes, that's exactly.
Because right now it isn't.
Right. I think that would be useful.
I like that idea.
And then enclose and confirm are just sugar. I mean, sugar is massive. It's not derogatory to say that. They're just convenience ways to make throw and catch be more convenient.
Right, and I guess there's some details that are like, so for example, if I provide handler function here, presumably that's called regardless of whether it was thrown with confirm or throw, right? Yeah. Okay. I mean, that I don't really see look, at some level, I think this is a pretty safe thing to do because if you've given your confirms and your throws the same tag, like it's pretty hard to accidentally do that at some level.
Well, the only point here is throw becomes the sort of the equivalent of confirm assert of true or false.
Not quite, because I mean, depending on, so I mean, I guess if we went with like what Jose was saying earlier a little bit, but the point is confirm assert, no matter what happens, no matter what you put in it, will always throw a failure object, and you can stuff the failure object with whatever you want to stuff it with, but so throw could throw actually anything.
But then the enclose function would get run on the thing that has been thrown.
Right. The handler function will get run. Yeah.
Right. So maybe we should talk through the lexical thing. So just to be clear for everybody, the idea is this case here with confirm in the function foo, not lexically inside the enclose, would not work unless there was a tag given. People understand that, right?
Yes.
Only something where it's enclosed, like module, if you say there's an inner, it's literally lexically enclosed in the enclose. I mean, it seems like the right thing to me. It seems like a good way to do it because it's a very common case. And, if you do want to do the long distance confirm, then you put in a tag.
I think if we document the heck out of it, I won't complain.
Yeah. I mean, I think that the right, there's a question of how to document the heck out of it. I mean, the only I mean, by the way, just in terms of long-term encloses, I think that the way that you actually want to do that is you want to do something like this, right? So I'll put my untagged one there, and then I put an enclose, in that function, and then when I call this function, because I've looked at the source and I see it has an enclose around it, I know that it's kind of a function that might throw, and so I'm gonna propagate that error if there was one. I think this is, I mean, this is even, we talked about this last time about with throw and catch, whether or not you should throw all the way to the top through all the functions you're calling, or whether you should sort of catch it at each step. And I think that right now, throw and catch, it's too painful to catch it at each step. But that, you know, sort of semantically, that is the more beautiful thing to do, which is what this is.
I mean, my concern is that if you end up with a lot of confirms in the code, and there's a working within a framework, it's useful to know that I have this safety net and I can punch out to it whenever I need to.
Sure. I mean, where you mean that the safety net's all the way at the top.
The safety net is, the enclose, a tagged enclose, all the way at the top.
Yeah, I think in a lot of your graphics code, for example, Brett, that's exactly what you would do. You would just somewhere
right,
deep
and that's
wrong.
what I would continue to do.
Right.
But I think my impression was that was, what Christopher doesn't envision as the paradigm.
Well, I mean, but then that's the reason why you would have a tag, right? Why it's possible to supply a tag.
I suspect the following is true. If you are designing a large code base where individual functions deep inside the code base will never be called on their own, your punch out mechanism is the right mechanism.
Right.
If, on the other hand, every function deep inside the code could be called on its own, you need something more like this, where the functions propagate, because each individual function, you don't want, in your case, if you had uncaught confirms from deep in the code, that would be undesirable. In other words, somebody called one of your deep functions directly. In other words, you never expect your deep functions to be called directly. You do not provide that interface.
Exactly.
So I think is that a correct difference here? That if you expect every function to be callable, then it's more sensible to have these more local confirms and enclosures.
At some level, it's just a question of whether you like side effects, right? If you have a big piece of code and you have lots of little functions that, again, are never going to be called outside of this big piece of code, then it's very natural to have side effects, right? And then there are other cases where, the structure of your code is different, or your coding style is different, and then, you maybe don't like side effects as much.
Can we get some pieces of code?
Christopher, sorry, can I ask a question? That in 91, could you take out the enclose? Yeah, take the enclose, just have, right, fine. Now evaluate that. And then can you evaluate foo2 of $failed?
Just on its own.
On its own.
Yeah, so this, okay, that does this.
Right. You see, another possible answer for that is it would just return $failed. No message, it would just return $failed.
Or the failure object itself.
Or the failure, or the failure object.
I think to do that, you need that, again, you need that third argument to throw, but yes, that could be a behavior.
Wait a minute, it would do that by virtue of returning from the foo2, or by virtue of returning to the REPL?
It would return, that would be the result of foo2.
Right.
Oh, the result of foo2.
So you're arguing that down values should get automatic
encloses.
If and only if they have
untagged confirms.
Yeah, I'm just saying the scope of that confirm is lexical. It's just within the function.
Well, it's not within the function. It's within the down value.
It's within the definition that's given here.
That's the definition of the function.
Right. But I'm just saying that as somebody who regularly writes functions with multiple down values, right, each down value is sort of separately in its own enclose, assuming they have confirms.
Yeah,
right.
Somebody earlier made a point about, if you have enclosed around the outside, at least from a documentation perspective, like it seems like it's very easy. You could read the function, see that it has an enclose around it, and then like I should use confirm when I call this function. But if it's kind of implicit, if there's a confirm anywhere on the body, it's less. You have to go through a bit more work to look at the body of the function to determine if you need to confirm it or not.
Wait a minute. If you need to,
like this is the case is like
I have a function, and it might, at some level, my function might return an error, right? It might return a failure object because I have confirms inside of it, and maybe there's an implicit or explicit enclose around it, right? And now I'm going to call this function from another function. It's nice to know, oh yeah, this is a throwing function. This is a function that might give me a failure object, right? And an enclose
like
around
the
that is kind
implicit
of a
enclose,
marker.
Yeah, is kind of, it takes away that information of, I can just read the, just scan the definition and see that.
Well, but to be fair, if there is a confirm with a tag deep in the function, you still could have that risk, right? If there's a confirm with a tag, it's going to blow out of that function and go,
True, yeah, but somebody was pointing out earlier, like, I think the general style that we'll see if we adopt this is, internal functions use that tag and public functions don't. So, this would kind of become, not really part of the documentation, but, part of, like, if you're learning a new piece of code, it's helpful. Whereas if you have a really internal function that uses a tag, hopefully you're not calling that anyway.
Well, that discussion was when
system, but
that discussion was when we were having a purely dynamic enclose and confirm. If we have a lexical one, I don't see why internal code would need tags if you're just doing everything lexically.
I mean, the only case is the Brett's case, right?
Yeah, exactly. That you have a mix of lexical and dynamic.
I think this is obviously silly. This thing about having auto enclose for.
I guess then there's the question of what about the right-hand side of rules and replacements, or is it really magically tied to down values?
One thing I thought about, would an attribute make sense? Like auto enclose or something? That you could set so that all down values of a particular symbol do that?
I think that people wouldn't in practice do it, because I think that's a, but let's talk about the rule case. Does the rule case make any sense? In other words, the activation, the replacement of something by a confirm, is that a reasonable thing to do? And then, I mean, if you do colon greater than confirm, it's just executing the confirm. And if it's lexical,
yeah, I mean, I think that the point is, right, you need to, when you write an explicit enclose, you're saying this is where the error should run up until this point and then should stop propagating, right? I think if you have like a rule or something like that, it's too vague. Like the function case could work because it's pretty, if you're looking at a piece of code, it's pretty obvious. Yeah, this is the end of the function.
Right, and I suppose if you just happen to write I guess that's an interesting question. So assuming we had this auto behavior, would that be overridden by an explicit confirm? Because suppose I had, an explicit enclose. Because suppose I had an enclose and then I had a replace somewhere inside of that enclose with confirm. Would that, assuming we implemented something for rules, would that be restricted to the rule, or would it jump up to the whole down value?
I think it's one of many good reasons to not implement this for rules.
Right.
Yeah.
Because if I wouldn't want my rules to suddenly stop matching because I used confirm inside one of them.
So just a couple of things here. So I mean, it sounds to me like nobody sees anything horribly wrong with these mechanisms. And there's concern about the word confirm just being sprinkled throughout code, but I think it's a heck of a lot better to do that than to have all kinds of to have two other possibilities. One, no error handling, or two, grotesque procedural code trying to do error handling. Now, the question is, could there be or should there be an even shorter form of confirm syntactically? Is that useful, or are people going to end up using confirm match and confirm by almost as much as they use confirm? Anybody got an opinion about that?
I mean, I think that people probably will use. I think that confirm will probably be by far the most common. Like at least in the examples that I've played with, that I haven't had to use confirm by and confirm match nearly as much. And I mean, I think that. Right. I mean, especially if you're propagating lots of errors, then you can use just normal confirm.
So there's a question here, which is,
Go ahead.
Auto-suggesting of adding confirms using code assistance. Is that feasible? And what would we want it to do?
You see an if statement where the third part is a throw, suggest changing it?
No, but I mean, yeah, well, that's a good start. Yes.
Well, so if you had this idea of, right, if enclose, if we imagine there is no implicit enclose, they're all explicit, right? Then like Connor was saying, you can have something where if you just look at the function and you see, oh yeah, the outside of this function is an enclose, then you kind of know it's a throwing function. And then if you call it, maybe you can suggest putting a confirm around it because you know that it might throw.
Well, and also if it needs an explicit enclose, then clearly in the case you've written for foo2, the foo2 definition there, the code assistance tools can tell you to put the explicit enclose there. Otherwise, what's it going to do if you don't have the explicit enclose? That thing is going to put a tag into the confirm, and the tag will never be caught.
Yeah, I mean, so this is why. Oh yeah, this is why there needs to be a third argument for throw. Is this exact case right here? But yeah.
Right. Okay. So I mean, I do think this auto enclose is actually a fairly good idea for functions, but. Okay, so I mean, what will be the heuristic for deciding when a confirm is worth putting into code, other than in the case where it's an if throw?
You mean for code assistance?
Yeah. I mean, does anybody know, maybe Brenton knows, from existing categories in the linter, is there something obvious? Are there types of functions where you should say, should this have a confirm? You could say every time there's a division, you could say, should this have a confirm for the divide by zero case?
Yeah, I mean, the thing that I'm worried about is that I haven't really looked at these kinds of patterns before. They're definitely, anyone that I'm prefacing with, if anyone comes up with patterns of, like you're saying, if, the throw, whatever the example was earlier, I can definitely add that to some assistance tool, obviously, but existing patterns, for error checking, well, I mean, they would all be variants of things like, using if something,
no, but I'm taking a different example, right? So I mean, you could see a piece of code that says, A over B, right? And the question you might ask is, what if B is 0? Right? Now,
I mean, I think if you provide a suggestion that says you should wrap you should use a confirm because maybe B is 0, I think that's a little pedantic.
Well, that's a question. Is there a heuristic that allows us to determine? Go ahead. What?
No, sorry. I mean, it's just that, so everyone here knows this, but for the sake of just clarity, Wolfram language is very, very dynamic. And it's very hard to say anything about static analysis of Wolfram language is very hard. And
well, I understand, but that's what I'm asking about. Like A over B, what are some examples? So A over B is a case. We're talking warning messages, error messages, et cetera, et cetera, et cetera. Is 1 over 0 a warning or an error?
Well, what are you saying? A over B or 1 over 0?
Well, even just, but by the time, look, if you've got A over B in the code, okay, there are certainly cases where one could look at the code and say, gosh, this is going to fail if you have 1 over 0.
Right, but the thing is, it's power of B to the -1, actually. But
so what? I mean, my point is still...
Well, it would be a warning on any power to a negative exponent. You could have...
Right, well, you might have, but I mean, that's what I'm asking. Is that, you say that's too pedantic.
No, I'm not saying that. I'm
but
just...
it depends on what you're trying to do. I mean, if you're trying to write a piece of absolutely bulletproof code, that is a case that you might care about.
So, I mean, is this something that, I forget if this is a thing that the linter does, but are there like linting levels? Like, can I set the linter to -- pedantic and get these sorts of messages?
Oh, absolutely. Yeah, there are a few different dimensions in the linter, and there could always be more dimensions, obviously. I've projected them down to only 2. There is severity, and there is confidence level. There could be more like intentional and other stuff, but there is severity, and that means warnings versus errors versus fatal.
Yeah. Which will be a mess for exactly the reasons Roger has described.
And then there's also confidence level, which is saying, how confident are you even that this is even a problem, of which we can only reach 100%, confidence level in syntactical wrong, missing packet type errors. Everything else, strictly speaking, is less than 100% confidence level. And so I mean, it's just it's a matter of dialing in how pedantic you want. You lose if you want less confidence.
Right. So just to give another indication of a confirm case, if you're returning an entity property, right? In principle, you could find out, could it be missing, right? And we could even have a table of which entity property pairs, which entity type properties have missings in them. Because there may be somewhere there's just no missings. If you ask for the atomic number of a chemical element, there will never be a missing. If you ask for the
although some of those could also change in principle, but yeah.
Yes, they could change. They would have to be maintained. I mean, that's an example where, go ahead.
Your 1 over x, I agree, it's a pretty common case. But if you draw that to its conclusion, what you're saying is that for every singularity of a function, you should have a warning, right? Because the 0 happens to be a singularity of the power to the -1,
sure.
Right? Okay. Well, we have lots of functions with lots of singularities.
I know. So it's probably hopeless. And 0 times x.
And you divide by 1, and you need to look at all the zeros of that function.
Right. I mean, plenty of times I get 1 over 0 somewhere, and I get a complex infinity, and I say 1 over that, and I get 0, and I'm very happy. It was exactly the correct behavior. Right.
I mean, right. And then there's also, again, drawing to the conclusion, there's also stuff like every time you run part, should it tell you, oh, you should make sure that you have enough, that the list is long enough, right? It's like,
I mean, in an ideal world with a dependent type checker, yes, but.
Right. I think folks on our live stream are not understanding some of what's going on here because the fact is, just type 1 over 0 just for the sake of understanding what actually happens.
Okay, yeah.
But
okay, now type 1 over that. Well, just type 1 over %. Yeah, I mean, it's that's the life of a symbolic system, is you can get all kinds of things here. Right.
You were saying about properties of entities. Yes, that's an example. As long as the string of the property name that you're supplying, all of that's everything we're talking about is lexical. That could definitely be maintained. A table of known properties and all of that. That could definitely be known statically. And I mean, yes, that is another example. Yeah.
But so in your example of GDPs, that is a piece of code which I can guarantee will fail some of the time because there are missings, because there will be pieces that are missing. So if you saw that piece of code without any confirms in it, you could reasonably in the code assistance system say you probably want to put a confirm.
There are ugly ways of doing it though. Like, for example, some people might do this, right? Is that, comma. Right. I mean, there's an example of a not particularly nice, but works piece of code. It does something slightly different, but
it does something slightly different, yes.
But there's no need to put a confirm there.
Well, also being able to put that confirm, detect that lexically is very complicated because that's a thing where it was inserting the entity value things through through that function.
Sure.
But okay, I'm just throwing out examples, but I'm just asking, is there a reasonable set of heuristics for deciding when the code assistance tools should suggest inserting a confirm?
The first thing I'm going to do with it is make another function called confirm 200 that for every HTTP request goes in and checks that it's a 200 status.
Yeah, this is the
right. I'm just going to make a utility function.
Way to do that? What's the minimum?
Like if you use URL read, you can get the status code out of it.
Yeah, that's what it's called.
Some of my code is still calling URL fetch, and but with URL read, exactly. Yeah, I'm going to define this as a holding attribute function, and I'm going to use it all over.
Right.
I could even
now,
say,
well, now
I'll say
try
this
something.
of body. Right, so in that case, it got the body, and now what's something that won't return 200?
Just type of some random
How
gum.
many O's can you put in Google?
This, though, I don't think will quite work, though. Oh? Wait.
I bet you can put a lot of O's in there. Just put some other junk.
I didn't know that.
Okay, but now see, this is a case where you'd have to do a layered. This is maybe something. This is something that was brought up earlier.
Show it first. Show it first. Show the first
Okay.
thing. Show what it does.
Okay, Google. So this will be a problem still because this actually returns a failure object in that case. But if I do this, then it should work.
Yeah.
Right.
It returns. I see. It returns a
No,
failure
there's no
object,
of body.
as
If I got rid of
opposed
the
to it's
confirm,
an HTTP response with a different response code.
If it was a good domain but a bad path, you'd probably get the 4.
Well, so in
O's
fact,
or
that's the
something
case where you
result.
want show that code because it's interesting to see that it's a confirm by and a confirm that are needed.
yeah. In this particular case, actually, you don't need the confirm because, in fact, failure of status code equals 200 returns false. But yeah, but that's by coincidence.
Yeah, it's just a coincidental thing.
Yeah.
How common is it that you need nested confirms like that? Probably not very common. It's for functions that return failure and have another condition associated with them.
Yeah. Yeah. I mean, this is the thing
Language
is
has
that I think
static type information. No, this language is about as far away from having static type information as you could possibly imagine. Everything is an expression. The compiler tries to derive static type information, but that's a whole different issue. Yeah, everything is runtime here. So, by the way, is it worth just talking briefly about the what are you doing here? Oh,
So
I'm just getting it.
I have a question. So Bob was saying, the first thing he was going to do is go off and create his own confirm function.
Right.
And so then that basically means that has to work in a tagged form, right? There's no.
Oh yeah, it'll be tagged. Yeah. When I do, but sure.
What do you mean?
There's sort of no way
I see.
to extend the lexical version.
Oh, that's interesting. So in other words, he couldn't put a confirm 200 and expect it to be caught by an enclose without tagging the enclose.
Hmm.
That's an interesting.
That's a very interesting point, right? Well, okay, so what's,
I mean,
what's
I could imagine some system where you register new confirm functions and then the
lexical tagger picks them up.
Yes.
That seems very complicated.
Well, and also there's complicated stuff because you need to define. So here's a funky little thing, right? So confirm has multiple usage lines, but this is the only one that actually needs to be implemented with the symbol called confirm, because basically, if the symbol called confirm is ever run without a tag, right, then something has gone horribly wrong because there should be an enclose around it that gave it a tag, or it should have a tag already. And so these other cases are all implemented only for quotes local confirm, the like module variable, right? Because the other versions will never ever get run. So there's an example of why this also becomes more complicated. Because I mean, you sort of need to, yeah.
We don't have any mechanism for user level scoping construction, right? You can't make a user level. I don't think you can make a
variant of width or something.
Yeah, I don't think you can do that. And I mean, the fact that hasn't been a big sort of issue.
That one way of doing things like that is with a macro system where you convert into.
Okay, we should wrap this up soon. Did you want to say something, Christopher, about the headdress version of this for
yeah, so I mean
more local?
Yeah, I mean, so this is an example like for here. So one weird thing that you can get is, okay, so let's suppose, this piece of code could be much longer, right? Like I could use hash part 1 in a bunch of cases, and I could use or maybe, you know, I'm using apply. And so it's #1 and #2, right? I could use #1 in a bunch of places, and separately I use #2 in a bunch of places. So the question is, do I put confirm around every single time I use #1? Because that seems a little bit painful. So, I mean, one way of getting around that, you know, would be if you had some sort of, you know, headdress or something, which basically runs confirm on the arguments.
So write that out as it would be with confirmed. I don't think it is. That's not right. It will be a confirmed in the.
This is.
That's not right. It will be a confirmed in the divide.
Yeah, you're right. You're right. So it would be.
You have to have a divide. You have to call it divide. You have to say confirmed of divide.
Yeah, actually, this particular example doesn't work because of where the enclose is. But so the point is though is you know, like, let's say I'm mapping, you know, if I'm mapping some function that takes, you know, an argument hash, and I use hash at many different times inside the pure function, do I confirm it every single time I mention it? So, I mean, one solution is to have a headdress, but part of the problem with a headdress is that there are many different types of confirm right now. And so, you know, are you going to also have many different types of headdress confirms? I mean, you could, but it seems a little bit weird.
Well, and is it even useful? I'm concerned that this multi-argument form is not particularly, that there are very few cases. I mean, like, take that divide case. It's a total mess.
Why don't let me write out a concrete example. So suppose I have this, and suppose I want to get, you know, I want hash part1, or let's just get the GDP, right? So we'll just get, you know, hash squared over hash plus hash minus hash, right? Not a very profound function. So am I supposed to write confirm around every single time hash appears?
Okay. And what's the alternative?
Well, so the alternative, I mean, because the alternative would be something like this. So let me put this back. You could have something where well, okay, let me write this a little differently, because again, this is a bit of a.
I don't think it's going to work.
Why wouldn't that be the same as just using it on one of them? If you're clever to the first one that the evaluator sees.
Oh, that's good.
That you can absolutely do, but that requires you knowing which one the evaluator will see first.
That's not terrible. I mean, that's not a terrible thing. But even in that case, nothing's going to happen. It's like echoing one of those hashes. So long as you do it for one of them, the actual function isn't going to run until they're all, you know, that's a good strategy, right? You just confirm one of them.
Well, so, okay, but so now what about, I mean, but there are cases where, for example, let's say I have f of this one, and f is a, you know, hold all, some sort of holding function, right? So it's going to run all of this.
No, then it's going to mess up.
Right. So you need to know a little bit about how the evaluation is going to work before you know which one.
I think the same is true with echo, and people do manage to do that perfectly well. But so what's the case? I mean, it's seeming to me like the case of the maybe like construct for is not convincing.
Well, that's a different.
I mean, you could always just do, open bracket confirm of hash semicolon, and then whatever you really wanted.
No, exactly.
Close bracket, right? You could always just do that, and then
That's true. That's very true.
It's an idiom, and it's not beautiful, but that would work, right?
Yeah.
Also, you could have a second function that just takes a single argument of that you say is confirm, you know, that supplies.
Yeah, right. You've nest the functions.
Yeah.
Right,
So
I mean, there's the case though that you're talking about, the thing about the use of the word maybe. That's this other issue, which is about sort of single level error propagation, which I think is a totally separate question.
Okay.
But which has to deal with the case of, I want to map over some data and some of it is, you know, missing, let's say, and I just want it to, you know, I just want it to automatically propagate this missing up. I mean, basically it's a function where it's like, you know, that wrapper basically, you know, and maybe it can be more general than missing Q, but.
And how would you do that with confirm and enclose?
Well, you could do it with the confirm and enclose, but the way you need it, it's one of these naked, it's like an enclose of, it's this. And then Well, okay, actually, this is how you would do it right now. A little funky.
Which is also speaking to Jose's point about the hash information thing.
Yes. By the way, the word information is probably not right.
Right. Yeah, it's a, well, I don't know what it is.
Like
It's a payload, but that's also really weird. Content, something. All right, we should probably wrap this up. There just persistent comments on our live stream about categorizing types of errors, which, I mean, we really think is impossible. So it's this point about halting execution. See, we don't have a notion of halting execution. Nothing halts execution. A warning is something a compiler would point out would cause a potential problem. We don't have a compiler.
Yeah, I mean, the only equivalent to this is like actual syntax errors, which already get, handled, so to speak.
Right. I mean, I just think that this is, look, I think we should get this system in and start using it and start, for example, so I would imagine that there is if we think about the workflow of writing code, some code will be born confirmed, so to speak, with confirms in it. Other code, like, for example, function repository code, I could imagine will be initially written without this, and then this will be added as an outer, added as an add-on, so to speak. Is that what people imagine, or what do you think? What do you think for people actually writing code? What will be the typical pattern? I mean, I think that prototype code will not have this. As you try and make the code sort of bulletproof for production, which is the time when right now you're adding all kinds of weird procedural throws and catches and so on, that's when you would put this stuff in. What do people think about that? And that's why I keep on talking about code assistance as a way to help people to, quotes, put it in. I mean, is that the right workflow, or should we expect something different?
I mean, I have thought the point is to, and certainly what I would value out of this is that it's so trivial that I can write it correctly the first time around.
Yeah, I think that's basically right. I mean, except that I think that it will be
right. But no, you're talking about writing it the wrong way and then later.
No, I'm talking
putting
about
it in throw and then putting
look,
in the confirms.
Let me give the example. I have no idea. I mean, if you let me share for a second, I had some function up here.
Itai, some of us aren't capable of perfection the first time like you.
Yeah, I mean, so this is some random function, and this has been rewritten since I wrote it, but I wrote it a few days ago, and it's been rewritten since then. Like, I bet there are cases that if I thought about it, I realized that there are edge conditions here where it could fail, right?
That first slash at position, I guess it'll still be okay. But if it was first at position, it would potentially be
yes,
wrong.
It could potentially be wrong, right? And that's a great example of where I would think, Brenton's tools could tag that as a thing where you might want to confirm it.
Or another one is the evolution part, all comma one, the first line basically. Evolution could be could be an image.
This does not check. Right, so this is a great example. This doesn't have checking code here, right? Probably should have. But at the very least, the next level of bulletproofing would say, well, what should this say? This is confirm quiet, basically, on this.
You could confirm quiet, or another thing, I think slightly cleaner, but a little more verbose would be if you did like confirm assert at the beginning, just to insert that your inputs are sensible.
Okay. Another, in the graph where there's a join, you would want to check that the things have the same head, or that the result is not head join. That's a common thing.
Well, but that's bulletproofing beyond. I mean, this should be correct because I just derived it inside here.
Well, like as in you should bulletproof inside of head dependencies and tape dependencies before you instead of bulletproofing around join. Is that what you're saying?
Sorry, what are you saying?
You wouldn't bulletproof around the join because you would already have bulletproofed inside of head.
Yeah, that's what I'm suggesting. But I mean, the question is, how much bulletproofing should one have? Like this particular thing, and this is something that could be known to the code assistance tools, that can't fail. If hash is a list, you can always do that.
I mean,
Whereas
this is just a. I mean, are you talking about in relation to what people should do, or are you talking about in relation to what code assistants should tell people to do?
How do we know hash is a list?
well, position updates is a list because it's the return value of position.
But I mean, this is very deep analysis that we're talking about, though. I mean, it's trivial for humans to be, reasoning about this, but like, this is very. Could this be special cased? Yes, obviously, but we're talking about very deep analysis.
No, I understand that. So in the near term, code assistants will not be able to do this. I'm asking, what is the workflow that we expect for people? Right? Like I wrote this function fairly quickly. It somehow got rewritten by somebody because I wouldn't have used those particular variable names. And the question is, when it goes in the function repository, by the way, somebody has a bunch of background noise they might not know they had. When it got put in the function repository, it would be desirable to, to somehow do some bulletproofing on this. And the question is that an add-on thing that, what will one expect this will look like after it's been bulletproofed? Will it have confirms sprayed all over it? Will it have a couple of confirms? What will happen?
I think that the thing is that this is not a great example because at some level, this is a function that can always run as long as evolution is something sensible. It'll always work.
Fair enough.
All you really need to do is assert that evolution is sensible. I think a better case would be something that's like doing networking, or it's calling functions that sort of heuristically try and work but don't always work, and stuff like this, right? Those are the functions where you really.
I was going to say those resource functions are potentially hitting the network.
Yep.
In the vertex style and the edge style.
Yeah, that's true.
And I can tell you something that will be very useful for code analysis and determining all of these kinds of things. If all of these functions have tests that can be run, then hearkening back to the first half of this session, we could run these functions instrumented in some way, these tests, and we could actually just have tools that notice whatever these invariants are, hash is a list, and all these kinds of things, in lieu of having an actual type system. You have to figure stuff out at runtime, but we have a runtime system. We can run a bunch, if we have tests that cover a lot of our bases of how you expect something to run, we could notice what all of these things look like when you're running tests, and then give suggestions based on that data that, from code that has run.
I see.
It's hard to talk about code in Wolfram language that hasn't run, but we can also just run code though, if we have tests and things. So it's not so bad. Sometimes, and the heuristic, invariants aren't going to be perfect. We will miss some, we will have false positives and false negatives, but I think it would be perfectly reasonable to come up with some kind of 80% solution of keeping track of and whatever the invariants are that can be easily noticed when you're running tests of all the functions.
So I mean, this would be an example of a slightly more realistic, complicated thing. Wow, why is there a red color there? Wow, that's wild. It's not a thing one sees very often. Something that's actually red. Wow, that's really weird.
I think it's a dynamic module versus module question.
But why is it? I mean, I don't even see why it went into scope or out. Oh, it was passed in the module. I don't understand that at all. But in any case, this
it's inside of a dynamic, but the variable is in a module. I think that's the problem.
Yeah.
Oh, wow.
It should be in the dynamic module. That's been read since like version 5 or something.
But is this in fact an error?
It's an error that they should have put it in the dynamic module. Yes.
God, why didn't they notice that? Well, in any case, somebody is commenting on our live stream. As a programmer, I don't want to do error handling. Yeah, well, that's what we're trying to do. Is we're trying to automate it as much as possible. But in the end, yeah, this is a bad example. It's too long. I was thinking this might have some other types of things in it.
Well, no, I mean, this is a realistic, I mean, that's a very formatted piece of code, but I mean, this is somewhat realistic. I mean, that you'd maybe put enclose around the, create document there, and who knows? I mean, look, there's even the replace. That replace there is a classic, classic idiom that you would want to replace with a,
Yes.
Yeah.
Yeah, I don't know what the heck this is. I mean, this is some weird.
In that case, it's not. In that case, it's trying to use resource function, but if the resource function's failed, it's just going to use the symbol that's already there.
Right. I mean, that's local error handling. That's not a confirm thing.
I don't really even recognize what this is doing, but I mean, the question that looks grotesque, but this is not going to be safe.
There's a common idiom. I think it's different from what's happening here, but there is an idiom which is I call some function and then I use replace, basically like if, and I say, if it was something silly, then replace that with message and throw.
Or with whatever value I want to be the default.
Well, sure. I mean, the second one is is I think good, and the first one is a little bit funky. Like that's the first one is what I think you want to replace with confirm, but the second one is legitimate, I think.
Okay.
Or confirm. What is it? Confirm match, I guess. Right, because oftentimes they write it that way because it's simpler. Or perhaps more readable than if of match Q of blah, blah, blah.
Yeah, you use confirm match to be analogous, yeah.
All right, we should, wow, there's a comment about inherited block. What is inherited block?
It's a block where it's internal inherited block, and it's block where things retain all their definitions.
It's in the function repository, which of course has some overhead, so you might not want to use it, but the documentation is good.
And what does it do again?
It what it does. So Stephen, instead of create value, okay, which creates a new value with cleared stuff, it does a create value where it keeps the old values. It's used for things like NDSolve to implement evaluation monitor and step monitor. And
what do you mean?
Look at a second example. Look at a second example there and compare it to what block would do. Right.
I see. So it can overwrite the value, but it saves the. No,
It doesn't start with the value cleared. It starts with the value having its current. Which, right? So rather than trying to, right? Because you can't really, I mean, you could do it for own values, but if you want to save, all the values, you can't really do that with block.
Right. Fair enough. Okay. Well, it's at least in the function repository. Comment from Mohammed on the live stream. Fair enough. Okay. Well, look, this to me, this looks. I mean, there were a few comments there and a few things worth thinking about, but otherwise, I think we should be good to go to try and get this into the 12.2 prototype builds. That sound reasonable? The enclosed confirm stuff.
I think so. I mean, I think it's one of those things where we're going to have to get our hands dirty using it, and then we'll.
Right. That's what I think too. I think the earlier it is in builds, the better. And I mean, I'm not sure what's going to happen in terms of code that starts to use it. I mean, maybe it should try to get into the head branch quickly enough that people can actually start writing code with it, because that's the only way we're going to know if it's right, is substantial pieces of code written with it. Anybody want to comment on that? Christopher, did you get all what you need to get the build environment working and so on?
Yeah. I think I'm set up to do that. I mean, the only detail is the 3-argument throw, which just breaks it in one particular case.
Well, so that has to be redone. Can you do that, or does that require somebody else to do that?
I mean, I'm kind of set up now to do it, but yeah, I mean, I don't know. I mean, I'm not super, my knowledge of kernel code comes from reading it. But, I looked at this and I don't think it's a super complicated change. Like, I think I already know how to do it.
So you're an expert then now, Christopher.
Yeah.
All right. Oh, well, I will reassign all throw, catch, and other exception bugs to you now. Excellent. Thanks for volunteering.
I mean, the only detail about that change is that I think you have to make throw hold all, because right now it doesn't. Assuming that the third argument is like time constrained and it's something that will be evaluated and run, as opposed to it being a function, yeah.
Well, but what would it do? It would evaluate immediately, as if the other arguments, it would evaluate immediately as if it was not hold all.
Yeah.
Anybody see an issue with that? Okay, well, let's wrap it up. Okay, thanks everybody, and thanks to people on the live stream for comments and people who were. I have the impression there were some people who are not very familiar with Wolfram language. This was a very bizarre way to see the very bizarre introduction, because this is looking at a very piece of meta programming, so to speak. Yeah, check out some other introductions. Okay, thanks all. See you all soon.